What is up, good people? It's so good to be here. I'm very excited to record this first video and very excited to start in September and walk with you through your Honors Algebra 2 journey. Let's get right into it with a little bit of housekeeping first. You'll notice that this is what I call fill-in-the-blank notes. You should have a packet in front of you. You should have a pencil or pen to write on that packet because there's empty blanks and there's spaces for you to write. And what I'd like you to do, just to keep your task as simple as possible, is to basically just fill in the blanks. So here on your packet in front of you, you should see you should see a blank here, and I'd like you to write the word input. I'd like you to write the word output. I'd like you to write the word exactly one. It's just one small way to stay kind of like, to make sure people aren't dozing off in front of the screen, and also to make sure that so you're being a little bit active. And also, I'm going to check the next day to make sure that you filled in those blanks, and that way I know that just one small way that you're being active during this time and thinking about what's going on. I'm going to go kind of not really at a fast-ish pace, but I'm going to keep things moving and kind of minimize the amount of downtime. Mostly so that the video doesn't drag on too long. I know people don't have an infinite attention span, so I want to keep things moving, so I leave it to you to slow things down and to repeat things, to pause things if you need to think about it. You're going to Google something, pause the video. That's your responsibility and your opportunity, and I leave it to you to take that. But even if you do occasionally slow things down or pause them or repeat them or go back 5 seconds to listen to something again, sometimes you'll just have a question, and that's normal. Like, no video can perfectly explain something to you or to everyone all the time. There's going to be lots of questions. Even if I do a great job of making an awesome video, there's still going to be lots of questions because everyone comes from different places and different backgrounds. So what you've got to do is you've got to hold on to those questions. You've got to record them and bring them to class the next day. It's going to feel a little weird the first couple of times, but just like this whole idea of like delaying the gratification of getting a question answered. But of the years I've been doing this, students get used to it within the first 5 videos or so, and that's in the first week or two. So what you might see at the very bottom of your packet, there's space for questions. And so here is a great place. You don't have to write it here, but you can write it anywhere you want. You've got to bring your questions to class. We are going to have a great conversation, I'm sure, about your questions, and I want to know what they are so that we can just empower you. Write down the questions and bring them to class, and we'll get them answered. Next, also down at the bottom, you'll notice that there's a place for an audio check. I'm going to throw out random information, like in chapter 1, it'll be about who I am as a person or who I was in high school. And so you can write that down. It's just a way for me to just make sure that people have their headphones in and they're listening, or you're listening to my voice. And just a simple audio check. Next, you'll notice that there is a red dot here, and every section has one red dot. And I just want to know whether or not you can figure out what number goes underneath the red dot. It's going to be part of the Ed Puzzle questions you see at the end, just like the audio check. So when we get to the place of the red dot, go ahead and fill it in, and then it'll be a good way for me to check, to see, it's good data for me to see if lots of people are able to get the red dot question correct, then that means, we don't have to explain a ton. But if everyone's getting it wrong, then we might need to slow things down and figure out what's going on. It's good data for me to have. It's probably a good exercise for you to do also, just to check to make sure that you're doing things well, and that you're tracking. That's a good check for understanding. All right, so let's jump right into it. Here we go. Functions and continuity, chapter 1, section 1. A relation is a pairing of inputs to outputs. So you'll see right here is a pairing. 1 pairs to C, 5 pairs to A, 8 pairs to B. There should be a second parenthesis right here. It's missing. But this is, if the input is 1, then the output is C. If the input is 5, then the output is A. If the input is 8, the output is B. Oftentimes these are strictly numerical, like you input one number and you get another out, but it doesn't have to be. And oftentimes these are not just listed out, but they're also defined with a rule. So like if the function is the add 5 function, then the input was 0, then add 5 to get the output, you get 5. If the input is 1, add 5 to get the output of 6. Right, and you might see right here, it numerically defined as well, like that. The domain is the collection of relations input that produces an output. So you've got all these red numbers here, and if you collect them all and you put them all in a set, just a bag that has numbers in it, then the domain is 1, 5, and 8, and the range is the collection of relations output produced by an input. So the range is the collection of A, B, and C all put together in a set. Function. Now, a function is a special kind of relation that pairs each input with exactly one output. So this is a relation, as I've said. It also happens to be a function. It's a special kind of relation because every input has exactly one output. Now, if I were to add a fourth arrow here going from the 1, not just to the C, but also to the A, like I'm saying here, then it would not be a function. So, because you wouldn't have each input going to exactly one output, this particular input would go to 2 outputs, and that would disqualify it from being a special function. It would only be just a normal relation. So here's what that looks like on a graph. Here is the add 2 function right here. This is if you've done algebra 1, you might know this as the line y equals x plus 2. Well, you could also just think of it as like take an x value and add 2 to get the y value. If the input is 0, then the output is 2. If the input is 1, then the output is 3. If the input is 2, then the output is 4. So you can see this is a function right here, and I've graphed it. You take any x value and you add 2 to get the y value. This is what it would look like. The vertical line test is a way to see, given any particular graph, is that if every vertical line touches the graph at most once, that's what you should write down. So if every vertical line touches the graph, then it is a function. So this is a vertical line, and you can see it touches at most once. Here, the vertical line touches the graph once right here. Here's a vertical line, it touches at most once here. You could draw another vertical line and see it would only touch once here. Here's an interesting function. It's one that's curved, and you might not have ever seen anything like this before, but you can take each one of these x values, pair it with, each one of these points is a coordinate pair, an x comma y, a number comma number, and we could list a lot of points out and know that this is the function. Anyway, it's a vertical line that only touches once. Here, same thing. This function goes up and down quite a bit, and you could list them out numerically, but graphically, if you can draw vertical lines and only have it touch once, it's a function at most once. Now here's a circle. Notice we've got the points 2 as the input and 4 as the output. 2 is the input and -4 is the output. There's a vertical line, and if it touches that graph twice, then it is not a function, because you can see right here, the input 2 has 2 different outputs. If I say the input is 2, tell me what the output is, you could say 4, you could say -4, and that would disqualify it from being a function. Graphically, we see that with a vertical line touching 2 points. Here, this is even worse. You could see, if I said, all right, I'm thinking of a point on the graph, and the input is negative, the x value input is -3, what's the output? And you'd be like, I don't know, it could be 3.5, it could be 2, it could be a -1. This is not a function, because I can see that at least one input, like -3, has more than one output. So, it's easily seen or easily tested with a vertical line. If you can draw a vertical line that touches more than once, it's not a function. Here's a whole collection of points that have turned into a function, and you can see the input is 3. What's the output? Well, it could be +2, it could be -2. This is a relation, yes, but it's not a function, because at least one input, like 3, has more than one output. When we're looking at graphs, you can see the x values are going to be the domain, and the y values are the range. And if it stops right here, if it goes from here up and then back down and then up again, then only these numbers are in the domain. You can see the collection of all the x values of all the points on this entire graph. There's lots of them, but the collection of all of them would be the domain, and the collection of all the y values here would be the range. Now, here's something that's going to be a little tricky and strange to get used to. I apologize. I wish it were different, but it's not. This is the way we write things out. And actually, it does have advantages later on. You'll see it, but right now it might feel just strange and new and weird. Now, I know all of you who learned really well from your Algebra 1 teacher what this looks like. This is 3 times the quantity x plus 1. And most of you be like, oh yeah, and I can distribute. You get 3x plus 3. Great. There's unwritten multiplication right here. There's addition here, and there's two operations. There's addition and there's multiplication. However, here is how we write rules for functions. This is what's called function notation. F parentheses x parentheses. This is not multiplication. You'd be like, what? It's not multiplication. I see a letter, I see a parentheses. It's like up here, like there's unwritten multiplication here. No, this is what might look like a strange way of writing out a function. Let me explain to you what this is. This function is defined by a rule, and it takes as its input the x. And function notation specifies you have f and then parentheses of x. Like you say f of x. Repeat after me. Wherever you are right now, say f of x. Let me hear it. Okay. F of x, and that's how you say this out loud. What that means is it's the f function. The name of the function is f. There's also the g function or the h function or the v function or t function. But the name of this particular function is the f function, and it takes as its input variable an x. And it's defined anytime you want to find, given any particular input, if you want to find out what the output is, what you have to do is you have to take that input variable, like if you give me the input of 11, then you add 1 to it, and then you divide by 2. So 11 plus 1 is 12, divided by 2 is 6. If 11 is the input, then 6 is the output. This is what that looks like. Now, equation table graph. This is going to be super important. Anytime you need to graph something, you've got to make a table first. And you might say, hold on, Mr. Bergman, I know how to graph without a table. Maybe you do with lines, but in algebra, we're going to start to get to curves. So I'd like you to practice, and if it's a new habit, I'd like you to practice this new habit of making a table. The phrase that is going to encapsulate this whole idea is equation table graph. Let me hear you say it. Equation table graph. Louder! Equation table graph. Yeah, right. So if they give you an equation like f of x is equal to 3x minus 4 or y equals 3x minus 4, then the first thing you got to do is make a table. And what you do is you choose your x values, and you can just choose, for right now, for this particular one, I know, because I've done several of these, I know I can just choose like some easy numbers like 0, 1, 2, 3, and produce the outputs. So you choose the x values, and you calculate the y values using the rule. And this is the way you read it, f of 0 means I'm taking the f function, not the g function, not the h function, not the v function, but the f function as it's defined here, and I'm putting as its input 0. That means, and the rule is, you take the input 0 and multiply by 3 and subtract 4, and you get an output of negative 4. Here, take an input of 1. F of 1 is 3 times 1 minus 4. That would be negative 1, because you do the multiplication and then subtraction. Now, technically, you don't need to do 4 of these rows in order to figure out where this is. Mathematically, 2 points will define where the line is, and if you do this perfectly, then you don't need to do any more. I kind of recommend, especially when it comes to like testing or quizzing purposes, you want to make sure you did it right, then do 3 lines, and if they all coincide, then you'll know that you did it right. 2 is the input, so this is f of 2 is equal to 3 times 2 minus 4 is equal to 2. And so each one of these rows corresponds to a point, and they all are in a straight line, and everything is good. Make sure you're copying this down. It's in green, and it's not in the packet, so fill in the blanks. Now, this might be a little new. I don't know if you've ever seen what's called a parabola. It depends on your Algebra 1 training, and everyone in the class has probably got something different because you came from different schools. But if it is our job to make the to make a graph, it says graph the function, then you can't just start out with a graph. You've got to make a table first. You've got to do all the work. And it's not great to do that in your head. You really should be doing it on paper. It'll go faster, it'll be more reliable, and you'll be able to proofread your work. You can't do that in your head. So you can choose x values. When it comes to parabolas or functions that have a squared as an exponent, I think the best thing to do is to choose 5 points for 5 rows. So you need 5 input values. And for right now, we'll just choose 0, and then a couple numbers, a couple negative numbers, and a couple positive numbers. I always think that starting with a negative number is kind of like the hardest thing to do. So the hardest row is the top one. So why don't we start with an easier one, like 2. F of 2 means take the f function. Now f is defined as 3x squared minus 10, and replace the x with a 2. You're going to take so here we got 3 times 2 squared minus 10. If you're going to do PEMDAS on this, remember you got to make sure you do the exponent first. That's 2 squared is 4, and then do the multiplication times 3 is 12, minus 10 is 2. Here, if the row is 1, f of 1 is going to equal to 1 squared times 3, which is 1 squared is 1, times 3 is 3, minus 10 is negative 7. 0. F of 0, this whole term becomes 0, and then subtract 10, you get negative 10. All right, let's take a look at the negatives. And here we got to be a little careful because it's tricky. What you need to do is write -1 inside parentheses, because if you do that, it signifies that the entire -1 is being squared. If you don't write it in parentheses, then sometimes that can be mistaken as 1 squared and then make it negative, and that's not what we want to say. We don't want to say 1 squared and then make it negative. We want to say -1, the entire thing times itself twice. -1 times -1 is +1, multiplied by 3, and you get 3, and subtract 10, you get negative 7. So, with that in mind, -2, what is -2 times itself twice, times 3, minus 10? If you do that, you'll find out what the output is when the input is -2. F of -2 is equal to what? You can pause the video right now and calculate that out if you need to, but in any case, we've got these points plotted. And if you extend, let's talk about these arrows. You won't, gosh, I wish Desmos, and I wish all calculators, and I wish all textbooks, and I even wish that in my packet I would see consistently these arrows. These arrows mean that the line or the curve is going to continue on in the same direction forever. And you know that if you chose higher input values, you get higher y values. It just keeps on going. It extends off the graph. And you can't see it. Here, the same thing occurs as well. You can see that the number is getting more and more positive if you choose x values further away from 0. So you can connect the dots and know that it's going to be this kind of U that will keep on extending higher and higher and higher, and keep on getting steeper and steeper and steeper, and go as far left and as right as you can. Now, question, how do we know if these are functions? Do they satisfy the vertical line test? What is the vertical line test again? Vertical line test. If every vertical line touches the graph at most once, then it is a function. It's kind of like these two examples right here. You could draw as many vertical lines as you want. It would only touch once. All vertical lines touch once. So therefore, we're not ever going to see, like if the input is 0, then there's only exactly one output. We'll never see 2 different outputs. So for that reason, it's a function. All right. One thing I wanted to say is that about me personally, if you, I don't know if you know this, but the one way that I'm most famous at SCH. It's not because I'm a great teacher. It's not for my teaching abilities or the way that I really care about my students. No, that's not how people know me at all. People know me because I'm the stroller guy. I'm the guy who pushes his children. I've got 3 of them. Two of my older 2 go to SCH as of the time of this recording. So I'm the guy who everyone sees either on Mermaid Lane, no, Cherokee Lane or Mermaid Lane, or wherever it is, pushing his kids to school. I'm the stroller guy. While running, it's a great way to start the morning, and it's a great workout that I get. Keeps me positive, keeps me fit, and saves a little bit of gas in this, for climate change purposes. It just really makes me really feel good about it. I love it. If you've ever seen me pushing a stroller, if you've ever seen anybody pushing a double stroller with 2 kids in the middle of the road, it's probably been me. So welcome to my class. Let me know. Anyway, I can't wait to hear what questions you came up with, and we've got some activities related to vertical line test coming up. So bring your questions, and I'll see you in class.
Hey everybody, I want to show you a website we're going to be using a lot for math. It's called Desmos. If you've never seen it before, it's pretty amazing. I want to show you right now what the calculator looks like. So you can do a Google search for Desmos and go to the graphing calculator if you like. I personally have this website bookmarked. The Desmos calculator right there, so because I use it so much and you're going to use it a lot too, feel free to bookmark it if you want. The graphing calculator looks like this. Notice a couple of things. Here's a graph. That's great. Also, notice over here, I haven't signed in yet. I love Desmos deeply with all of my heart, but one of the things that I don't like about Desmos is that you have to press login every time and continue with Google. So now it knows who I am, and if you see your name up here, you should actually go to Desmos right now. Maybe split screen what we're doing, the video and this, and you should also log into Desmos, because I'm going to ask, you're going to do some things, and then I want you to bring those things to class tomorrow. Alright, so Desmos, here we go. We've got, first of all, we can just type in an equation like 3x plus 1, and you don't even need the y equals or the f of x equals in the front. It already assumes that you want to graph it, which is really great. I'm going to change this settings. The wrench here is the settings tool. I'm going to change it to kind of large screen, easy to see, and just for your sake, but you can also do it if you want. Then next, I think what I'm going to do is I'm going to turn this into a table. One of the big themes in this class is equation table graph. So let's type in the word table. Table. I just type in T-A-B-L-E, and then you could also, if you wanted to, do this plus bar, you can add a table this way. Anytime you want to add something, plus, boom. Okay, so if we wanted to, what we could do is we could type in some x values like 0, 1, 2. Oh, it already guessed that the number 2, I would want that, so I'm just going to press return a whole bunch of times. And it knows. It guessed the pattern. Alright, here's one thing I can do. If I wanted to make a table out of 3x plus 1, I could do 3x, and then I'm going to type a 1. No special characters necessary, just 3x1, and it knows that I want a subscript. And then plus 1. And so right away you can see that the points are being graphed on the table. These blue dots correspond to each one of these rows, as you can see blue. If you wanted to, you can long press on it and change the color. Let's change it to green. Boom. Let's change it to squares. That's what you get when you can long press. I think I like the solid dots in the first place. Okay. Exit out of that. So there it is. That's one thing you can do. Now, what I actually prefer to do, you can always do it this way if you want, but actually what I prefer to do is type f of x equals. It's not going to change anything here. You can see it's the same. And then I'm going to put it all here. F of x1. Just so that I can kind of separate it out and a bit more easily manipulate this if I want to, change it around if I want to. X1 here, and then f of x1. It's going to take, it recognizes that the f function is here defined, and so therefore it's going to take all these x1 values. X1 is really a list of numbers that you can see here. It's going to put that list into the function, and then the output is going to be a list, and they're going to graph these two. So there it is. Now, one thing you can do is you can change it here, and you see all of a sudden it's f of x plus 2. Like when I changed f here, it changed the list down here, which is really great. Very easy to manipulate. I'm going to change this to a shift to the exponent and then type a 2. And all of a sudden you can see we've got this really strange U-shaped curve, and we'll talk more about that later. Anyway, how about this? How about, here's a really wacky idea. I'm going to, instead of a number, I'm going to type a letter, like A. And it's guessing that I want to add a slider. So yeah, I'll add that slider, and now I can move the slider up and down. Whatever A is, it's gonna look here to figure out what it is. And all the numbers on the table change, and all the graph changes as well as I slide A up and down. Pretty fun. Why don't you play around with this, modify a little bit, and then notice the second thing. Again, I love Desmos so much, and we're going to use it a lot this year. But the second thing you got to get used to is that although Google Docs automatically save, we come to think that the work that we do online automatically gets saved thanks to Google. But unlike Google Docs, Desmos requires you to actually press the save button. Yeah, so you got to make sure you sign in and save. And I'm just going to say this is homework 1.1. Save. Now you can see I've got a list of all my of everything that I've done. And if you click those 3 bars, you'll see it come up as well. Anyway, why don't you play around with it, make some modifications, find something cool, type it out, and save it. Bring it to class and show me or show the people you're sitting next to. And I can't wait to see what you come up with. Take care.